Yeah, we got to go the distance. I like that last line there in that song. And as far as going the distance in Algebra 2 Trig, the good news is this lesson marks the halfway point. You have successfully survived the first half of Algebra 2 Trig, and it's you can finally see the light at the end of the tunnel. But we're going to continue to build on some of the reflections and translations we talked about yesterday, and we're going to apply them to two really, really special graphs. And the two that I want to cover today is I want to review what y equals e to the x looks like. We've seen that on a lot of bite-sized quizzes lately. And then his inverse function, y equals natural log of x. Now real quick, e to the x. When you go to sketch that, I want you to get in the habit of drawing the asymptote first. A lot of us have been giving me the equation of the asymptote, but we haven't drawn it. I want you to show me that it exists. And then the curve shoots skyward like this. So the asymptote is at y equals 0, sitting right on the x-axis. Its y-intercept is at 0, 1, and those are the two important features. When you get to the natural log function, again, let's get in the habit of drawing that asymptote right away. Show me that there's a vertical asymptote right on top of the y-axis, and that's at x equals 0, and then the graph shoots this way. It's increasing, but at a decreasing rate. You know, it gets increasing slower and slower. The x-intercept is at 1, 0. So what we're going to do is we're going to work on reflecting these rascals. Oh, one more thing I almost forgot to mention. Let's start with this idea. Go back to E here. The domain, we would say, is all x values such that x is an element of the set of real numbers, aka what that means is it goes infinitely to the left and then infinitely to the right. It extends infinitely in both directions. The range is going to be all y values such that y is greater than 0. Remember, it's not equal to 0 because that's where the asymptote is. Switching over here to the natural log function, the domain this time is going to be all x values such that x is greater than 0. Aka everything to the right of the y-axis, and then the range are going to be all y values such that y is an element of the set of real numbers. And again, that just means it goes infinitely low and infinitely high. Alright, for our first example, we're going to build off of the function e to the x. What if I said I wanted you to graph f of negative x? First of all, if you did the substitution, you would get e to the negative x. And as soon as you see that negative sign inside there, we're negating x directly, which means we are going to reflect our graph over the y-axis. All right? So, quick little sketch here. We're going to, let's see, if I visualize that horizontal asymptote and I flip it or reflect it over the y-axis, it actually ends up landing on itself and we get the same thing. The only thing that really changes is the fact that now my graph's decreasing. Still has the same y-intercept, it's just decreasing. The domain would actually be the same and the range would actually be the same. We just got to flip it over the y-axis. Our second example is going to be just a little trickier. I've given you the function g of x, defined as the natural log of x. If I wanted you to negate g of x, this time instead of just negating x specifically, I'm really asking you to negate the entire function. So what we're going to do is that's going to be the negation of the natural log. And anytime you see the negative out in front of g like that, that indicates that it's a reflection over the x-axis. Okay, so if we wanted to graph that, just visualize your original natural log curve. And if you pictured that vertical asymptote and you reflected it over the x-axis, it would actually end up being the exact same. The function would just now do this. Once we flip it upside down, it would still have the same x-intercept of 1, 0. It would have the same asymptote. It's just now it's a decreasing function with the same domain and the same range that it had earlier. Now I think it goes without saying today is like everything is kind of predicated on the fact that you have a firm grasp and understanding of the basic functions e to the x and natural log of x. It's hard to really be good at all these reflections and translations if we don't have the basic version memorized and under control. But anyway, my next one is a translation, and I'm going to ask you to do f of x minus 2. Now keep in mind, when I show that notation, I'm asking you to take the quantity x minus 2 and substitute it into the original x. So now my function looks like this, and that minus 2 is part of the exponent. Now yesterday you talked a lot about the fact that anytime that minus 2 is inside the parentheses, that indicates that it's a horizontal movement or a horizontal shift. Okay, and in fact, those are a little tricky because it's the opposite of the sign that you see. Well, actually, when you see the minus, that means we're going to go to the right 2 units. All right, so what's my graph going to look like? Well, when you take a horizontal asymptote and you slide it to the right 2 units, it actually, for all intensive purposes, remains unchanged. It's still right there at y equals 0. But now I want you to keep track of where you used to have a y-intercept right here. We need to slide that bear 2 units to the right so that it's over here right now. And then from that point, the rest of the curve pretty much shares the same pattern. It's an increasing function, concave up. And what we're going to do is we're just going to label that new point. We're going to say that's 2, 1. And if you labeled the asymptote in that one point, it used to be the x-intercept, but it no longer is the x-intercept. Or sorry, I should say the y-intercept. If you label that 2, 1, you're in great shape. Now, as far as the domain and range go, let's see. The domain, now the graph still extends infinitely to the right on this side and infinitely to the right on the other side. So I'm going to say all x values such that x is an element of the set of real numbers. And again, that's just our fancy way of saying infinitely to the left and infinitely to the right. Our range, let's see, our range are still going to be all y values that are above the x-axis, and aka anything above 0. Remember, the shortcut there is it's always going to be y is greater than the horizontal asymptote that we wrote earlier. So if you know where your asymptote is, you just tweak that a little bit and you know what your range is. All right, building off of that one, what if we wanted to do f of x, close the parenthesis, and minus 2 here? What we're doing is we're saying take the entire function that you started with and then just subtract 2. So now the minus 2 is no longer in the exponent, it's down on the ground where the e is. It's just a normal number. That has a huge impact. Yesterday we emphasized that if you see the minus 2 outside of the parentheses, it's now a vertical movement or a vertical shift. And we're just going to take everything that the graph used to look like and we're going to go down 2 units. Alright, so this is going to be a pretty decent one to play with. Now, start with that asymptote. Notice, do you see the pattern? Every time I tackle e to the x, I start with that asymptote. Used to be on the x-axis, but I need to go down 2 units. So I'm going to put it down here now, and I'm going to label it as y equals negative 2. So I think that's pretty simple. Now, your y-intercept used to be up here at 1. I'm going to go down 2 units and put it down here, and then from that point on, the graph is just the same as the original. The new intercept is 0, negative 1. I think it's interesting to think about the domain and range now. Your domain, the graph still extends infinitely to the left, and it extends infinitely to the right, so that stayed the same. Wasn't too exciting, unfortunately. The range, however, we said it's going to be all y values such that y is above the asymptote, which in this case is negative 2. So we'll say all y values greater than negative 2 fall within our range. Oh, we're coming down the home stretch. We got 2 more to go. What if I took g of x and I asked you to calculate g of x plus 3? So again, we're asking you to take the quantity x plus 3 and substitute it into that given x value. So it's going to look like this. Again, notice the plus 3 is inside the parentheses. We know that anytime that value is inside, it's a horizontal shift. And this time, we are going to go to the left 3 units. So again, we have a firm grasp over what the original natural log function looked like. There used to be an asymptote on the y-axis, but now I need to go to the left 3 units. I'm going to put it back here. I'm going to label that rascal as x equals negative 3. And then now, there used to be an x-intercept right here at 1, but again, I need to back up, go left 3 units. It's going to land right here, and then build off of that. It's the original log graph. We're going to say that that x-intercept is now, negative 2, 0. Make sure the negative 2 comes before the 0. So as long as you label your asymptote and label what used to be your x-intercept, you're going to be in great shape and you're going to get full credit. Now, as far as let's talk domain. Does the graph extend infinitely to the left. No, it doesn't. In fact, it's going to be every x value such that x is greater than -3. Okay? What we're trying to say is it's everything to the right of the asymptote. That's where your graph lives, everything to the right. That's kind of another way of saying -3 all the way to the right infinitely to infinity. Okay, range. What kind of y values do we have? We've got every y value that goes as low as -infinity and it goes as high as +infinity. So we're going to say y is the set of all real numbers because it goes infinitely high and infinitely low. Now, if we define g of x as natural log of x one more time, but this time I asked you to graph g of x plus 4, ask yourself, what impact does that plus 4 have if it's not inside the parentheses? What if it's outside? It says, well, we're going to take the entire function, g of x, and then we're going to add 4 to that function. And again, the plus 4 is on the outside. There's no parentheses around that quantity. So we're going to say, anytime that plus 4 is outside, we've got ourselves a vertical shift, okay? And we're going to do exactly what we see. We are going up 4 units. All right. If we take a vertical asymptote and you slide it up 4 units, for all intents and purposes, you have the exact same asymptote you started with. We'll call it x equals 0. Now, we're going to take that old x-intercept of 1, and we're going to go up 4 units, and we're going to put it right there. So that's 1, 4, and then the graph just behaves like it typically would. Hangs around that asymptote and then breaks away to the right. The domain is going to be all x values such that x is to the right of 0. And then the range is going to be everything from -infinity to +infinity. So we'll say y is an element of the set of real numbers. Everything in there. Well, ladies and gentlemen, I hope you had some good practice with your reflections and your shifts. I hope they make sense. And I tell you what, make sure before you come to class tomorrow, you've really mastered those 2 original graphs, e to the x and natural log of x. Good luck. We'll see you tomorrow.